So let's try this sample problem. The floor system of a building consists of a 15 centimeter thick reinforced concrete slab resting on 4 steel floor beams, which in turn are supported by 2 steel girders as shown. So medyo dapat familiar ka sa load path dito for you to be able to answer this problem correctly. Okay? So, isa-isayin natin yung words that are mentioned on the problem. So, we have a slab, concrete slab, 15 centimeter thick. So, nakalagay naman siya dito. Okay? Resting on 4 steel floor beams. So, meaning, the whole slab that we have here, itong buong to, is actually being supported by floor beams, 4 floor beams. So, kung titignan natin siya sa elevation view, the figure looks something like this. So, this is the slab. And then, there are 4 floor beams that supports the slab. Parang ganyan. Okay? So, yan yung 4 floor beams na sinasabi dito. Si floor beam AE, BF, CG, tsaka si DH. Which in turn are supported by 2 steel girders. So, yung 4 steel floor beams daw na yan, according to the question, is being supported by 2 steel girders. So, nasa yung steel girders dyan? Ito si girder AD, tsaka si girder EH. So, ganito yung itsura nila. Ito si girder AD or EH. Nakaganito siya. Yan. So, yung support niya yung 4 na floor beam. So, paano yung load path natin dito? So, ang load path natin will be something like this. So, yung load, superimposed load that are being carried by the concrete slab are being passed through the 4 floor beams. And then, the loads that are being carried by the 4 floor beams are being passed or transferred to the girder. So, ganun yung load path natin. Okay. The cross-sectional areas of the floor beams and the girders are 94.8 and 37.4 square centimeter respectively. So, yung area ng floor beam, ito, nakaturo dito, is 94.8 square centimeter. And then for the 2 girders, AD and EH, their cross-sectional area is 337.4 square centimeter. The question asks for the dead loads acting on the beam CG. So this is the beam CG. And DH, this is beam DH, as well as the load or the dead load acting on girder AD. This is girder AD. So yan yung mga concern natin for this particular problem. Okay, solution. How to get dead loads. So we already mentioned how to get dead loads. Dead loads are just simply the self-weight of the members of permanently attached to the structure. So from the relationship of unit weight and volume, we have derived the formula for finding the weight. Weight is just equal to the product of unit weight and the volume of the member. Okay, but if ever the member is prismatic, meaning the cross-sectional area is constant all throughout the length of the member, we can transform the formula for volume into simply equal to the product of the cross-sectional area times the length. Okay, so we can use this formula for finding the total weight of each member that we are talking about here. So we have several materials here. The first one is reinforced concrete slab. The next one is steel floor beams. And lastly, the steel girders. So these are the sources of dead loads for this structure. The reinforced concrete slab, the steel floor beams that supports the slab. Ito, yung 4 na to. And then the steel girders that supports the 4 floor beams. Okay. So how do we get the weight or the dead load or the weight, simply the weight of the reinforced concrete slab. All we need to do is find the unit weight and then multiply it by the cross-sectional area and the length. You can already find the weight of the reinforced concrete slab. But for this case, usually for these problems, the problem usually wants to find the dead load in terms of force per length. So, gusto natin naka-force per length na yung makukuha natin dead loads dito. Hindi siya naka-concentrated load W. So might as well, yung length dito, ibaba na lang natin dito. Para nakadiretso na force per length yung makukuha natin na answer. So kung ibababa natin yon, matitira dito is gamma and cross-sectional area. Meaning, if we know the cross-sectional, if we know the unit weight of the reinforced concrete slab and the cross-sectional area of the reinforced concrete slab, we can get the dead load coming from that concrete slab. Okay? So how do we get the unit weight of reinforced concrete slab? We can refer to table 204-1 from NSCP C101-15. So we are using 2015 edition, guys. So we have a reinforced concrete slab. So it is concrete. So we will go to the concrete portion of table 204-1. So this is the concrete portion, but this is concrete plane. So we can't use that because that is plain concrete. We will move on to the next concrete that we have here, which is reinforced. So that is what we need. So there are three options for reinforced concrete here: cinder, slag, and stone, including gravel. So what we usually use here is the stone, or stone including gravel, since we know that reinforced concrete slab includes gravel. So according to this, the unit weight of reinforced concrete slab is 23.6. So we just list that here, and you have to realize that the unit of that value is equal to kilonewton per cubic meter according to the table. Okay, so that's for the reinforced concrete slab. Let's now move on to the steel floor beams. What is the unit weight of steel floor beams? So this is steel. The material is steel. So we have to look on the steel on the table. So punta tayo sa letter S. Ito yung start ng S, yung sand. But we have to look for the steel. And this is the steel. And according to that, the unit weight of steel, cold thrown, is equal to 77.3 kilonewton per cubic meter. Cold thrown yan, although dapat hot roll. Pero wala naman ng pang steel dito, so we'll just use that. Okay, and then the next one is the steel girder. So it is still steel. So same same unit weight lang, 77.3 kilonewton per cubic meter. Okay, so we already found the corresponding unit weights of each of the materials included on the problem. So it's now time to get the corresponding dead load coming from each of the materials. Okay, so let's start with the reinforced concrete slab. So itong reinforced concrete slab na to, this is just the elevation view of this floor plan that we have here. Okay, so kagaya ng dinrawing ko kanina, according to the problem, this reinforced concrete slab is being supported by 4 floor beams, which are this. Okay, at points A, B, C, and D, if we will be referring to this portion of the floor. Okay, and then in return, those 4 floor beams are being resisted or being supported by girder AD. So ganito yung itsura nila kung titignan mo siya sa elevation view. Okay, ganito yung itsura niya. Concrete slab, bali yung load path natin ganito. From the concrete slab, every load that the concrete slab carries are being transferred to the 4 floor beams. So naghahati-hati doon yung 4 na floor beams sa pag-support ng mga loads na kinikerry ng buong slab na to, buong slab panel that we have here. And then everything that those 4 floor beams carry are transferred to the girders AD and EH. Okay, so we'll start for finding the dead loads being supported by the being supported by the floor beam CG. Okay? But before we go with that, para malaman natin kung ano yung load that is being carried by floor beam CG, we need to find first the load being transferred to girder CG from the concrete slab. Okay, so we will start the computation with the concrete slab. Uh, we, for problems similar to this, usually for us to find the magnitude of the load being transferred from the concrete slab to the supporting beam, we usually use tributary area method. Okay, so according to the tributary area method, if the slab panel is one-way slab, so check muna natin kung one-way slab yung mga panel natin dito. When I say slab panel, it is the slab portion that are fully supported all throughout by beams or girders. So ito, isang slab panel to, isang slab panel yan, ito, another slab panel to, and then this one, another slab panel. Okay, so yung mga loads being carried by each of this panel are being transferred to the supporting floor beams. Ngayon, ang tanong na lang dyan, how much of the load being carried, say for example, by this slab panel are being transferred to the supporting floor beams, CG and BF. So since one-way siya, paano ko nalaman na one-way siya? According to the dimension, 3 at 3 meters. So ibig sabihin, ito ay 3 meters. And then ito ay 8 meters. So 3/8, that is, I don't know if you are already familiar with one-way slab and two-way slab, but I'll just write it down here. When we say one-way slab, these are slabs or slab panels that has their corresponding dimension ratio, shorter length over longer length, less than 0.5 or 1/2, less than or equal. May equal ba? Tayo lang isipin ko. I think may equal, yeah. May equal. So kahit so kapag yung ratio ng shorter dimension sa longer dimension ay less than or equal to 1/2, it is considered one-way slab. So according to the tributary method, pag one-way slab daw siya, yung load being supported by the slab are being transferred equally from to the two longer sides nung slab. So kunyari itong slab na to, meron siyang shorter span or shorter dimension tsaka longer dimension. So according to the tributary method, yung load na kinikerry nitong concrete na to are just evenly distributed dito sa dalawang longer dimension niya. I mean sa dalawang floor beam na located dun sa longer dimension ng slab. So ibig sabihin lang, yung bawat load na kinikerry nitong concrete na to or slab panel na to, yung kalahati napupunta dito sa beam na to parallel to the longer side of the slab panel, and then the other half dito napupunta sa kabilang floor beam parallel to the longer side of the slab. Sa shorter, walang natatransfer na load sa shorter beam na nagsusupport sa slab panel natin according to tributary method. Okay? Pag one-way slab siya. Yung slab naman natin dito, 3/8, that is less than 1/2 malamang. Kasi ang 1/2 ng 8 ay 4. And this is less than 4. So malamang less than 1/2 yan. Yung magiging ratio nila. Okay? So that is what happens kapag one-way slab yung slab panel natin. Again, take note yung arrow na dinrawing ko dito are load path. Hindi siya force or something. Load path yan. Ibig sabihin ng load path, dun papunta yung kinikerry na load netong slab panel. Okay? For the case of two-way slab, pag two-way slab, so kabaligtaran lang, ratio ng shorter length tsaka longer length or longer dimension, greater than as 1/2. Okay? So paano na yung distribution doon according to tributary method? So, ganito na itsura ng distribution niya. So, from the shorter side, drawing ka ng line, 45-degree angle, 45 degree. Ganun din sa kabilang side, drawing ka ng line na naka-incline, 45 degree, 45 degree. Tapos, kung saan sila mag-meet, gawa ka ng horizontal line doon, papunta doon sa kabilang side, kung saan mag-intersect din yung dalawang inclined or diagonal line na naka 45 degree rin. Okay. So, yan yung magiging tributary area natin for two-way slab. So, paano yung paggamit ng tributary area na yan? So, according to the tributary area method, pag two-way slab, yung mga loads that are being supported by slab are being transferred in this way. So, yung mga loads na nakatungtong dito sa area na to, dito siya matatransfer. Sa slab, sa floor beam, that is parallel to this longer side. Ganun din sa kabila. Dito siya matatransfer. Sa beam, that is parallel to this longer side. Dito naman sa kabila, yung mga loads acting on this triangle will be transferred to this side of the slab. Yung beam na nagsusupport dito sa side ng slab na to. And ganun din sa kabila. So, ganyan yung load path kapag two-way slab. Okay? And we will not use that here kasi nga, puro one-way naman to. Puro one-way, tsaka wala naman din talagang contact technically yung itong side na to dito sa slab panel natin. Kasi ganito nga yung configuration niya. So, wala siyang contact technically. So, talagang one-way lang talaga yung magiging behavior ng slab natin. Okay? So, kung titignan natin yung floor beam CG, may dalawang slab panel siya na sinusupport. Purahin ko lang yung ibang nakasulat ha. May dalawang slab panel siya na sinusupport. Itong slab panel na to, si BCGF, tsaka slab panel CDHG. So, meron siyang kinikerry na load from this slab panel and this slab panel. So, paano yung load na yon? So, ganun nga, since one-way siya, half-half ng load na kinikerry ng slab panel na to are being transferred to the longer portion. So, yung half dito nata-transfer, and then the other half dito. So, ganun din sa kabila, half-half. Yung load na kinikerry ni concrete slab, kalahati, dito na pupunta. And then, yung kalahati, dito na pupunta. So, kung i-observe natin yung si floor CG, si floor beam CG, ang load na kinikerry niya, dalawa. From this slab panel, tsaka from this slab panel. Okay? So, actually, pwede natin pag-isayin yung computation nun kasi kung titignan nyo naman, equal naman yung dimension ng tributary area dito, 1.5 tsaka 1.5. So, pwede natin pag-isayin yan, 3 meters. Okay? So, technically, ang magiging itsura ng floor beam CG natin, parang ganito. Ito yung slab panel area na kinikerry ni floor beam CG. And yung itsura ng portion ng slab na yan na kinikerry ni floor beam CG ay rectangle with a dimension equal to the thickness, which is 15 cm, and a width equal to 1.5 plus 1.5 or 3 meters. So, yan yung magiging cross-sectional area natin dito. Okay? Although, for generality lang, instead of lalagyan ko na siya agad ng value na 3 meters, tawagin ko na lang ito na double. Okay? Para maging general lang yung natin, yung pagkuha natin ng load being transferred to beam CG from the concrete slab. Okay? So, ang unit weight niya ay 23.6. Ito yon yung gamma. Yung cross-sectional area niya is just the area of this shaded portion, which is just equal to the product of this dimension, yung 15 cm, tsaka yung tributary width, na tawagin ko na lang na W. So, product nila. So, you just have to make sure na consistent yung units mo kasi naka-centimeter to eh. Tapos naka-meter to. So, you have to convert centimeter to meter. And paano i-convert yun? Multiply mo lang siya ng 1 meter over 100 centimeter since we know that 1 meter is equal to 100 centimeter. Okay? So, that is how we convert centimeter to meter. And then, do the numerical calculation na lang. Cancel yung centimeter. Cancel yung isang meter. May meter squared na matitira dito. And then, the result will be equal to this. 3.54 W. So ginawa ko lang siyang in terms of W for later computation. Okay. So next will be that. So this is the load that comes from the concrete slab. It will just be equal to 3.54 times the tributary width. Kung ano man yung tributary width mo. Kung 3 meters yung tributary width mo, substitute mo lang yung 3 dito. So makakuha mo na yung corresponding load from that slab panel or slab tributary area. Okay, so moving on to the steel floor beams. Yung steel floor beams, which are this, ang load na kine-carry niya, of course, from the concrete slab, pero sineparate na natin yung load from the reinforced concrete slab. So, ang computin na lang natin is yung self-weight ng steel floor beam na tinatawag natin. Okay, so how do we get that self-weight? Same formula. We just need to multiply unit weight by the cross-sectional area of the floor beam. And the cross-sectional area of the floor beam is already given, 94.8. So, do the numerical computation na lang. Substitute. Unit weight. Ito, cross-sectional area, naka-square centimeter. So, you have to convert that into square meter. So, multiply mo lang siya ulit ng conversion factor mo. But you have to square it para makancel yung dalawang centimeter squared. Ang matitira na lang dito, meter squared sa taas. May meter cube ka sa baba. So, cancel yan. May isang meter na lang sa baba. So, therefore, the resulting unit will be kilonewton per meter, which is the target unit for this particular calculation. We want our dead loads to be in terms of force per length. So, okay siya. Okay. So, do the same thing sa steel girders. Ito, yung si steel girder 80. How do we get the loads being carried by the steel girder 80? So, bukod sa loads that are being passed to steel girder 80 from the floor beams, of course, sinusupport ni steel girder yung self-weight niya. So, yun na lang muna yung compute natin kasi pinag-iwalay naman natin yung mga load being carried by each material. So, do we get the self-weight of steel girders? Same formula. Unit weight times cross-sectional area. This is the unit weight. The cross-sectional area of the steel girder are given 337.4. So, substitute na lang. And then, make sure consistent yung units, centimeter squared, multiply pa ng conversion factor. Do the numerical computation, and this will be the answer. So this is the self-weight of the girder 80. This is the self-weight of the steel floor beams. And this is actually the self-weight. Kung tutusin, self-weight to, pero ni reinforced concrete slab. Okay. So, puro na-compute natin dito, self-weight lang. Kasi wala namang binigay na superimposed loads. Especially dead loads, superimposed dead loads, so wala naman. So all of the loads that are being carried by each of the materials here are just their corresponding weight. Okay? So okay na, nakumpitan natin yung mga self-weight nila. It's now time to find the specific load being carried by floor beam CG muna tayo. Ito, si floor beam CG. Si floor beam CG, which is this, according to this drawing, ang kinikerry niya na load ay yung self-weight ng slab, pero hanggang dito lang sa tributary area, as well as yung sarili niyang weight. Okay? So, let's start with the self-weight of the slab. So, paano computin yung self-weight ng slab? We already found the formula for the computation of the self-weight of the slab. 3.54 W. W is the tributary weight. So, for this particular floor beam, the tributary weight W is just equal to 1.5 plus 1.5 or equal to 3 meters. So, substitute lang natin dito yung 3 meters. And then, we can already find the self-weight of the concrete slab being supported by floor beam CG pa lang. So, in addition to that self-weight of the concrete slab being supported by floor beam CG also supports its own weight, which we already computed a while ago, equal to 0.73 kilonewton per meter. Okay, so just do the numerical computation, substitute 3 meters here. So, may meter ka dyan, may meter squared ka, maka-cancel. And then, substitute, simplify. The corresponding answer will be 11.35 kilonewton per meter. And that is a uniformly distributed load acting here on floor beam CG. So, if you will try to imagine ano yung itsura niyan, that is just a simply supported load, uniformly distributed load like this. So, ang magnitude niyan, ng uniformly distributed load na yan, being carried by beam CG, is just equal to 11.35 kilonewton per meter. That is the answer for the first question. Okay? So if you want to find the corresponding reaction being exerted by girder AD and EH to this floor beam CG, kasi may reaction yung ano dyan eh, yung girder AD tsaka EH dyan, di ba? Exerted to floor beam CG kasi support nila to eh. Ito yung configuration niya, yan, di ba? Itong naka-perpendicular sa screen natin, ito si girder AD. Ito yan, kung titignan nyo siya dito. Girder AD. And then itong kabila, girder EH. Itong kabilang to. Okay. So sila yung nagsusupport dito sa beam CG. So kung gusto natin makuha yung reaction or yung force being exerted by the two girders to this floor beam CG. So since we assume na, di ba binanggit ko last time, pag sinabi nating beam, we assume that the supports of the beam is just simple supports. So simple supported lang siya pag sinabi nating beam. Okay, yun yung idealization natin for beams. We assume that they are just simply supported. Pag girder, we assume that they are fully restrained or fixed yung supports nila on both ends. This is for girder, this is for beam. So since beam lang si CG, nabanggit naman sa tanong, so we assume na simply supported lang to. So parang ano lang to, para ka lang may hinge dito, tapos may roller dito. So paano makuha yung reaction dyan? I suppose marunong na kayo kumuha ng reaction. Pero kung di pa, just get my attention and I will compute the reaction manually. But for now, since structural theory na kayo, I suppose medyo marunong na kumuha ng reaction. So gagamitan mo lang to ng kahit ano na lang, summation forces vertical na lang. Equal to 0. Okay, so sum up lang natin yung mga vertical forces dyan. Meron kang dalawang vertical force dito na naghahati sa total force coming from this uniformly distributed load. So, ang gawin mo lang, 11.35 times the length of CG, which is 8 meters. So, yun yung magiging total weight being carried by floor beam CG. And then, yung total weight na yun are evenly distributed from this girder and this girder. So, itong dalawang girder na to naghahati ng pag-support dun sa product ng 11.35 and 8 meters. So, kung i-divide mo yun sa 2, yung product nila, ito yung makukuha mo na sagot. Okay, 45.4 kilonewton. So, that's for floor beam CG pa lang. Let's now move on to floor beam DH. Ito. Let's try to find out ano yung mga loads being carried by this floor beam. So from this figure, drawing natin siya. So this is a floor beam DH. So ano yung mga loads na kinikerry ni floor beam DH? So una, yung load from the concrete slab, yung self-weight ng concrete slab. Ito, portion na yan. So paano makuha yung portion na yan na kinikerry? Again, we already know the formula, 3.54 tributary weight. Ang tributary weight for beam DH is just equal to 1.5. Okay, kasi 3 meters kada isang ano dito eh. 3 meters daw siya. So this is 3 meters kalahati, 1.5. So substitute lang natin dyan, yung 1.5, we can already find the weight of the concrete slab being transferred to the floor beam DH. And in addition to that, of course, si floor beam DH, supportahan niya rin yung sarili niya, yung self-weight niya. And we already computed that a while ago, that is also equal to 0.73 kilonewton per meter. So, substitute mo lang yung 1.5 dito, 1.5 meter, cancel yung meter, isang meter na lang matitira dito. Do the numerical computation, and this will be the answer that you will get, 6.04 kilonewton per meter. So, that is again a uniformly distributed load acting along the length of the floor beam DH. Okay? So si floor beam DH na yan, which is this, itong floor beam na to, is being supported by girder AD and yung kabila EH. So ito sila, dalawang support niya. If you just want to find the corresponding force exerted by the two girders to the floor beam DH, again, you can just assume that this beam is just simply supported beam and just get the corresponding reaction. So, multiply mo lang 6.04 sa length ng DH, which is also 8 meters. And then, divide mo sa 2 kasi nga, evenly distributed yan dito. Nagkahati sila equally. So, the result will be equal to this and this. So, equal lang yan. Okay? So, lastly, are the force or the dead loads being carried by girder AD. Ito, si girder AD. So, drawing muna natin si girder AD. Ito si girder AD. And it supports the loads coming from the 4 floor beams at point A, B, C, and D. So, ito si girder AD. So, yung mga loads being carried by girder AD are the loads coming from this floor beam, this floor beam, this floor beam, and this floor beam, in addition to its own weight. Okay, so in addition to the weight of the floor beam or floor girder AD, meron pa siyang kinikerry ng mga concentrated load or point load coming from the 4 beams connected to it. So, unahin natin yung magnitude ng force, dead load force that being transferred to the girder AD from this point, si point C. Si point D na lang. So, yung force na tina-transfer kay girder AD at point D ay, of course, equal lang dito. So, that is also 24.16 kilonewtons. Simply because connected yung dalawang yan. Ano, connected yung yung end ni DH connected sa end ni AD. Just like this. So, yung anything that girder DH carries are just being transferred directly girder DH, beam DH. Anything that the girder beam DH carries are just being transferred to the girder AD at point D. Okay? With a magnitude equal to 24.16, similar to this. Equal in magnitude but opposite in direction lang. Same goes dito sa kabila. Kasi kung mapapansin nyo, si beam AE, same lang din naman ng tributary width. 1.5 lang din naman. Similar to this side of the floor. Okay, so yung pinapasa na load from the concrete slab to AE, similar lang dito sa DH. So, same magnitude lang yung pinapasa na force ni beam AE kay girder AD at point A. So, 24.16 din. And then similarly, kunin natin yung point load na pinapasa ni beam CG kay girder AD at point C. So that magnitude is again equal to this force being exerted by the girder to the floor beam CG, which is equal to 45.4. And same magnitude dito sa kabila kay beam BF. Kasi nga, titignan nyo dito sa drawing, similar lang naman yung tributary area ng dalawang beam na yon. Parehas 3 meter yung width ng slab that they carries. Okay, yan. Parehas lang. Parehas 1.5. So, kahit i-compute mo yan ulit, yung load being carried by beam BF, same pa rin makukuha mo sagot. Okay, so those are the concentrated loads being supported by girder AD in addition to its own weight, which is 2.61 kilonewton per meter na na-compute na natin kanina. So this load can be idealized as a uniformly distributed load. Okay, so meron kang uniformly distributed load dyan in addition to the floor point loads coming from the floor girders, floor beams. Okay, so that is the answer for the last question. So kung gusto mo pa makuha yung reaction that column supports exerts to the two girders. So, ang girder, malamang ang support niya, column. Kaya nga natin siya tinawag na girder. Okay? So, yung column support ni girder AD, ito, dalawang I na yan. Ito yan. So, gusto mo makuha yan, you can just simply analyze this as a statically determinate. And indeterminate pala to kasi fix yung ano niya eh. Fix yung support na dito. Yun yung idealization natin eh. The girder the girder AD is connected to the column rigidly like this. So, meron siyang vertical tsaka moment dyan dapat. So, pero kung yung vertical reaction lang naman yung kukunin mo, medyo madali lang naman kunin yun. It's just the sum of the vertical loads being carried by girder 80 divided by 2 kasi equal lang naman yung kine-carry nitong dalawa. Pero yung moment, kung gusto mong kunin yung moment, medyo ibang way na. Ibang way na yung pagkuha nun. Since this is already a statically indeterminate structure. Although hindi naman hinahanap sa tanong yan. Hindi naman hinahanap to sa tanong. Okay, ang hinahanap lang naman sa tanong yung mga dead loads being carried by girder 80.